All right, so here we are starting up section 3, and I am going to be covering this lecture and replacing it with a new video. And just note that there is this external tutorial resource that we'll be covering. This kind of is, I'll cover like the first half of it this week and then the second half. But what it really covers is building this 3D clock. So if I move into a later part of our project, here we see that we have our UI we're going to continue working on our UI in section 3. We're going to have a slider here that lets us change the amount of time that the painting stroke can exist for. And notice it's updating the text over here. We've got glow and opacity sliders now we need to cover. The painting stroke looks a little different. And we have to cover these color sliders that now they're color tinted and they have a number to show you how much color is coming through. And this clock here is the big part of it. And it's going to take us about 2 weeks to cover this clock here. And so the clock allows us to change the time of day for our painting. So we have this AM PM, and we can click on these little hour indicators. And notice I'm painting as I'm interacting with the clock, and we will fix that later. So this clock, I'm going to cover how to build all the geometry parts and how to write all the code. But I also like this. This is an independent game developer who also writes tutorials. He's very good, and I like it's his introduction to Unity. It just covers like intro to Unity, intro to C#, Visual Studio, and I like how his perspectives are different than mine and what he chooses to cover. And so I think it's helpful as you learn these packages and this development environment to follow this tutorial too. But ultimately, as you take your time with it this week and next week, we're going to come down here. We're going to actually start to build the parts of the clock, which is what we'll be doing today. And then I'll get to about here for today, and then we get into building the C# scripts, building the programming that manages the clock and allows the hands to animate based on the system time. And this I'll be covering next week. So I'm just going to ask you to start moving through this tutorial outside class. All right, so where we left off from last week before we went into the quiz is we covered this this first iteration of our user interface, and I kind of built this whole thing, but on the right hand side, part by part. So if you notice in our hierarchy of game objects, we have our click detector, which is our has this script, this click position manager. This is like our major feature, which handles painting. We have our user camera that they're looking through, a light source, and then this big cluster hierarchy, our tree of game objects, is our user interface, and there's an event system that comes along for the ride. Let's see, we got text. Text is usually a way to inform the user what's happening, how to use the application. And then we also have text that can accompany more interactive parts of the UI. So like we have a toggle here that deals with whether we should use time destroy or not. So on off, which represents Boolean, true, false. But what does this toggle to? We need a label. So here's some text with that. We have a drop down, which represents an enumeration. Enumeration is a mapping of strings to ints, strings that are easy for humans to understand and ints for computers. And they're like custom lists that you can make that are very easy to select from. And we have our clear button, which is just a button click, is just like a quick method call. It's not sending any data, it's not any selection, but we do have size, red and green and blue sliders, which are representing floats. And we have this mouse position, which is like the one part of the UI where data is coming back to the user interface. It's going from our click position manager script to the UI. The rest of this data, which is going from the UI to our scripts, which is more normal. And how do we manage that? So we have this idea of an event system. So we never know when the user is using the user interface. We don't know which element of these that they're using. And so we have to follow like an event creations and subscription model where whenever the user interacts with any of these UI elements and an event gets fired off, and you have to first listen to the event. So when I talk about I talk about first person, I'm talking about myself as an object in object-oriented programming. So if me, an object, for example, the Click Position Manager, was interested in listening to these UI elements, I would have to subscribe to their events. And to subscribe to their events means I need to have a public method that I connect to, that I add to the event that makes it an event listener. So when an event happens, like this slider moves, like this green slider, I need to say, well, who's listening to that green slider? Well, that's why I have these public methods down here at the bottom of my Click Position Manager. And these are what are connect up to the events in the UI. So you can think of all these public methods as like the interface, the outwardly exposed part of our Click Position Manager object. And if I come to the top here, this is the class name. Here is all of our properties. You can get properties as like variables, values that we use throughout our object. These variables are able to be accessed in all of the methods and other parts of the object. And we use them in our big update loop, our big update method, when we're checking for user input and we're seeing if we have to create something. When we create something, we're using all of these properties to remember what we should be creating, how we should scale it, position it, and color it. And so these properties are set up at kind of the global part of the object, and they're set to some default values, and they're used when we create stuff. But what if we want to expose that to the user, allow the user to change that stuff? Well, then we need to create a series of public methods, kind of the interface of the object, and offer it up to other objects. And so that's when we go into, like, say, this slider component and say, hey, when you're changing, what are you going to be calling? Who is listening to your event? And that's a public method that sits on our Click Position Manager object. And that's the interface between the two objects. And speaking of which, the UI needs to mirror what our setup is in our object that is interfacing with the UI. So all of these default settings and these min and maxes that we figured out through experimentation, we do need to set up our UI to reflect the same. We need the user to interact with our object and have those numbers be the same on both sides so that everything matches up correctly. So we do need to be aware of our min, our maxes, our default values for all these properties, these attributes that are exposed to the user. And last week we went over this part, like left click to create, this big switch statement, how to manipulate the scaling, the position, the color, and the parenting of this object we're creating. And if we should be destroying it, we destroy it, and then updating the UI, the mouse position. All right, that's how we're able to draw with our update method and our Click Position Manager based on user input, and then have the UI reflect the state of our properties and update those public methods. And a lot of those methods, those public methods, all they're doing is receiving in a temporary variable coming from the UI, and they're just updating our properties. It's just like a wrapper for like these private properties. If we do want to update them, we offer up these kind of public interfaces, these public methods for them. So there's two parts in this script that I'll need to cover. before we can start building the clock. And here at the top of the update loop, we can destroy stuff. So right now, usually the objects we create are destroyed after a certain amount of time, but we can turn that off and they don't have to be destroyed like that. But now when we're painting we can't destroy, we offer up the option of the clear button. And I click that button and I can clear content off the screen. But we also wanted to offer up the situation of, well, maybe the user wants to right click and kind of erase parts of their paint stroke. And so to offer up this feature, let me just open up the click detector real quick to show you that everything I'm creating, if you remember, we're parenting it, it's underneath this click detector. And as I erase stuff, notice my list is now down to 5, 3, and nothing. So how do we do this type of erasing feature? Well, part of our update loop is now we can do an additional user input check. We can check if the input class, call this method get mouse button down, is true only when you first click. And what are you clicking? Well, 1 maps to right mouse button and 0 to left. So this is a right click. Or this can also be true if get mouse button down returns true when the mouse button is held down, and which mouse button? Right click. So this is true if we're right when we're right clicking, or when we're right dragging, we will then execute this code. And what is this code doing? Well, we're going to the camera class and we're getting the main property, which points to this main camera here, and it points to this camera component. This is the main camera. This is what the user is going to be using to look out into the world. Now, once we have that camera component on our main camera, we're going to call a method on it called screen point to array. So this shoots array out from the camera through a screen point. So think of arrays as lines or vectors that can be drawn and used in the physics system. And this requires a vector3, a screen position. So we do the input class, do a static property on it, the mouse position. And this is where the user's mouse is at that frame, at that moment. And this returns a vector3. And the x and y are useful, and the z is zeroed out. Now this returns an object of type ray. And that's great. It's done a lot of work for us. But if we want to use it later, we need a reference to it. We need to remember where this object is in memory so we can reference it later. So we have to declare a variable of type ray, capital R, coming from Unity Engine. And then we have to name it so that we can reference it later. So I just call it lowercase ray. You can call it whatever you want, but it equals whatever this creates. So we can have a reference to it, an object reference. Then we also have to create a variable of type raycastHit. And with those two variables, we can pass them in. Those two objects are object references. We could pass them in to this method call. We're going to the physics class, and we're calling the raycast method. It's a static method on the physics class, and it's going to shoot a ray out. And this is the ray, and this is the hit, the structure that will give us back all of our data if we do hit something. So this method returns true or false. It returns a bool. If it's true, it means we hit something that had a collider on it, and we're going to run this code. And if it's not true, we're going to do nothing. There's no else statement. So we don't do anything if there's false. So that's great that we know if something hit or not, but how do we get like more information out of this method call? You know, currently the return type is bool. It's not returning anything else. So we have this keyword out, and this is kind of like a modifier saying that this input parameter is not just going to come in in kind of a passive way. It's going to be like writable. It's going to be active. It's modifiable. You know, we're not just taking a copy of this instance and just reading it. We're passing in the reference to this object, and we're actually able to edit it, and it will come back out, with new data. So if this does hit something, whatever we hit, ultimately we're going to end up destroying it. So in the scene, actually it's fine. So let me unclick time destroy. Let me just paint a bunch of stuff and go into the scene view. And if you remember, this is the camera, and this is like its viewing angle. This is what it sees. And within the camera viewing angle, we do see the content we just painted. And if you remember, if I kind of zoom in, you can kind of think about this little rectangle right here as like the user's computer screen. There's a small little viewport, and the user was like moving the mouse over their screen. And wherever the mouse is at that moment, will shoot a ray out with that physics ray cast. And if it shoots out a certain amount of distance and it hits nothing, it'll return false. But let me just like select one of these spheres. If through the camera we're in a certain position, mouse position, where we shoot this ray out and we hit one of these spheres, because they have a sphere collider on them, that means they're part of the physics system, the ray will interact with this collider, and we will have a return of true. And then this hit structure, this hit object, will be updated, and we can use it to reference to be like, wait, what was this physics interaction? What was actually hit? And so this hit structure, it contains other things, but I think I might have it up. Yeah, I do. I went to Unity documentation. I'm in the scripting API, and the raycast hit object has properties that we can read, and we get the collider that was hit. We can get like the distance from the ray's origin. We get the point in 3D space where the hit happened. And we get the transform component that's connected with this collider. So we would do the hit, we would hit this thing, right? And when the hit structure comes back, we would have a reference to this collider object. Just remember, this is an object. It's coming from a C# script. We would also have a reference to this transform component, which is also just an object, a C# script. And we can grab it. So we can say, hey, something happens. Go get me this transform property of this hit structure, this hit object, which connects to whatever we hit. So this would be like this sphere here, this transform here. And we're at the transform component, and I don't want to just delete that. I need to go up a level. I need to go up to the game objects property of the transform. I need to go up to the reference to the game object. So the transform component is aware of the game object one level up, right? We want to delete this whole thing. We don't want to just delete this transform. Go up to the game object. You want to delete this whole thing. We could also have gone through the collider component, gone up to the game object. I just chose to go up through the transform. But ultimately, we go up to whatever we hit, and we get up to the game object reference, and we say destroy this entire game object. And that covers this part of the code. Let me know if you have any questions. And you can see it works if I go back in the game view and I'm right-clicking. And you can see over here these spheres, like the list is being changed. You can see this slider moving around. If I keep going, eventually, we're getting down to a smaller list of spheres. And right here, we just have 8 spheres. All right, I'm going to leave a few up right now because this will allow me to just talk about the next part. So when we hit the clear button, the clear button is generating an event, and we subscribed a listener to it, if you remember, and it was this public method called destroy objects. So this method will get called when the clear button gets clicked. Now, I did this kind of shorthand for each loop, but let me, a for each loop is like a simplified for loop. and it kind of abstracts away details of the for loop, so it's kind of worth going into what the for loop for this would look like, and then we can explain the for each loop again. So a for loop is a very commonly used looping structure. You may have heard of for loops, while loops, do while loops, and a for loop has a structure like this, kind of like a method with an input and a body, like a block of code. And within the input parameters, you have to specify three expressions. And so you have to initialize it. You have to be like, what is this iterative variable that we're going to iterate through? Because all a for loop is, it just manages how many times you're supposed to loop through this block of code, which is very useful. And so first we have to write like the initialization expression. So usually it's like int I equals 0. So we're going to have an int variable. We're just going to call it I for iterator, and we're going to set it equal to 0. And we're going to put in a semicolon, because that was like one expression, one like line of code. That was the initiation expression. Then we need some type of logical condition. We need a logical expression to know if we should actually evaluate the body of code or not. So in this situation, what we're doing is we're saying, hey, this click position manager object is connected to this click detector game object. It's right here. And next to it is the transform component. And it's this transform component that's in charge of managing parent-child relationships. So we see we have three children game objects right now. These are the spheres we've been creating. And so you can go into this as referencing this object, this component object we're working on. Go to the corresponding, the sibling transform component. And let me just, I think I have, did I have the transform up? No, but it's kind of useful to look at too. So the transform has some properties that are interesting, like child count, like the number of children that are underneath this transform. And you can also be like, wait, who's my parent? Who's the parent of this transform? You can look at kind of these hierarchies, but once I know how many children are, the most important thing is get child. I have a method where I can pass in a number here and say, get me the child. And just notice that the children are the transforms. You have to then go and get the game object if that's what you want. But these are collections, are lists, are arrays. And just know that when we count for an array or in a list, we always count from 0. So it's 0 to n minus 1. So here we have a collection or an array of 3 children. So this would be child 0, child 1, and child 2. So we count from 0 to 2. But if you get 0, 1, 2, that isn't 3 elements. So 3 elements, a list of size 3, but we count from 0 to n minus 1, which is 0 to 2. So what I want to say is, okay, we initialized our iterator, and now I want to say, hey, if the iterator is less than the size, what is it, child count? Yes. Is less than the child count, the number of children on this transform. So remember, if it's a list of size 3, we want to access child 0. So 0 less than 3, that's good. And when we iterate, increment, we move to 1. Is 1 less than 3? Yes, we want to do our code. And is 2 less than 3? Yes, we want to do our code. And then is 3 less than 3? No. So we don't want to be at the size of the list 3 because that's not an actual element. The last element is n minus 1. So once we do our logical expression, we end it with a semicolon, we have our update expression, our iterating expression. In the update expression, usually it looks like this. You just increasing iterator by 1. So plus plus just means update by 1. Just so you know that I plus plus is the same as I plus equals 1, and that is the same as I equals I plus 1. So even this, if you're just coming from math or something, this might look a little weird in computer science, but this is like saying we work on the right side first. We say take the current value of the variable and add 1 to it, and then store it back into the variable. So if it was 0, take 0 plus 1, the answer is 1, and store that back into our variable, and the variable updates to 1. So if you ran this again, it would be 1 plus 1, and then this becomes 2. And then this is a little bit more shorthand. This is like saying take whatever's on the left and add whatever's to the right. So take I, add 1, store it to I. And then there's even more shorthand if you're just dealing with ones. You could just say I plus plus and just increment by 1. But now in our for loop, we start off, we initialize. We have this iterator set to 0. And we make sure it stays smaller than the size of the array we're moving through. And then we increment it by 1, 3 expressions. Now what happens if it's valid? Well, we want to get the child in that position, and we ultimately want to destroy it. So now we can call the getChild method, and we have to say, well, which child do we want from 0 to n minus 1? And remember that returns back the transform component. We don't want to just destroy that. We want to destroy the entire game object. So it's like saying it points here, but I don't want to destroy this. I want to destroy this entire thing if the user wants to delete it. So start at int I is 0. If the list is 0, if there's no spheres underneath here, we have a size of 0, and it'll say like, is 0 less than 0? And that'll say, no, it's false. We will never go into this block of code. Now in this situation, we have 3. Okay, so we have, is 0 less than a list of size 3? Is 0 less than 3? Yes, that's true. So then we go in and we call this. There could be more lines of code in the block, but we're just dealing with 1. So we're saying destroy, go get the child transform underneath where we are, and which one in this list. So we're going to grab the 0, the first one, and we're going to go get a reference to its game object, and we destroy the whole thing. And then we move to this update expression. It happens after the body of code, and we increase this. This goes to 1, and then we evaluate. Logical evaluation is 1 less than 3. Yep. So go grab getChild1, which is the second one. Get its game object, destroy it. Increment this, another one. Goes to 2. Is 2 less than 3? Yep. So let's go getChild2, which is the third element. And let's destroy its game object. And increment this to 3. And is 3 less than 3? Nope. False. And then we leave. So we moved from 0, 1, 2. We moved through each element and we destroyed them. And I'll click clear. And that's what happens. All right. Is there any questions on this? Is a for loop, and this iteration is run once. Then we do our logical check. Then we go through our block of code. Then we go through our update expression. And then we do our evaluation. And whenever this turns false, we leave. And now for each is like a shorthand for that. You'll see these shorthands in like JavaScript and Python. And it's like you don't need to write all this out. You say, okay, just for each element that's in this collection, do this. And so this is like a reference variable. And this is like iterating through each loop, each step. So this is changing through the list. It says for each list, do that. All right. If there's no questions, I'm just going to stop it.